Hello there. I'm glad you made it tonight. Tell me, have you ever felt the quiet moment right before sleep when the world loosens and the night feels larger than the room you're in? That's where the stars begin to remember you. You breathe softly, and the universe exhales through you. Light that started its journey hundreds of years ago is arriving in this exact moment, settling gently across your thoughts. A soft shimmer across the dark. A warm echo of something ancient and patient. It's okay to drift slow. Somewhere above the silence, a star is cooling, another is being born, and their light folds itself around your breath. And as you settle deeper, the story opens into the relaxing science of how stars live and fade through cosmic time. You breathe softly, and the universe exhales through you. The quiet settles a little deeper after the hook fades, and we drift together into the slow beginning of starlight. A beginning so gentle, so ancient, it feels almost like a memory returning to us. Somewhere in the silence, the first warm glow is already forming soft as breath. You can rest now. We drift through the calm dark, letting the room fall away as a wider sky opens in its place. A sky before stars had names. A sky before stars had shapes. Only a soft ocean of hydrogen, thin as a whisper spreading across space that stretched for millions of light years in every direction. And as we move through this early universe, the quiet is comforting because nothing rushes here. Nothing hurries light. Nothing demands your attention. This is relaxing science in its gentlest form. You breathe softly, and the universe exhales through you. In the first few 100 million years after the Big Bang, the universe was a cool, drifting sea of hydrogen atoms, each one carrying a tiny piece of the future, each one waiting for gravity to gather them close enough to spark something new. It's okay to drift. The fact settles slowly into the story. Gravity moves with unimaginable patience. A single cloud of early hydrogen may take 100 million years to slowly contract into a warm, bright core. That means the universe's first stars formed in a silence deeper and slower than anything human time can hold. You can rest now. The fact settles slowly into the story. Gravity moves with unimaginable patience. A single cloud of early hydrogen may take 100 million years to slowly contract into a warm, bright core. That means the universe's first stars formed in a silence deeper and slower than anything human time can hold. This is where the first warm glow begins. It forms not suddenly, but in breaths of cosmic time. The hydrogen atoms drift inward. Gravity folds them closer. Each fold presses them tighter, bringing their energy together slow as a long night drifting toward dawn. Somewhere, light continues to travel. Inside these clouds, temperatures climb to 10 million degrees hotter than anything the Earth has ever known, yet born from the gentlest motion of atoms drifting together. At that temperature, hydrogen begins to merge, not violently, not explosively, but quietly, like two notes blending into a single long tone. It's okay to drift. This merging, what relaxing science calls nuclear fusion, is the heartbeat that forms a star. The first time it happened, the universe brightened its first candle in the dark. A star perhaps 30 times more massive than our sun, glowing blue-white, with fierce but elegant light. But from where we drift tonight, that light feels soft, gentle, like a warm glow blooming. You can rest now. We move closer, not with speed, but with awareness. In this vastness, the first stars shine for only a short cosmic moment. Some burned for just a few million years, vanishing quickly compared to quieter stars like our sun, which will shine for nearly 10 billion years. These first stars were enormous, bright, and brief, like cosmic lanterns, guiding the universe toward complexity. And as we drift with them, their light washes across us like water slow flowing over stone, warm, patient, comforting. You breathe softly, and the universe exhales through you. It's strange and beautiful to think that every atom in your body, every bit of oxygen you breathe, every trace of calcium in your bones was once inside a star like these. When the first stars lived and died, they scattered heavier elements into space, which would someday form planets, oceans, and everything alive. In the quiet between stars, you are remembered. We move as if we are floating inside a warm tide. The light deepens in color, shifting from a pale blue to soft gold, as we imagine younger, smaller stars forming later in cosmic time. Their glow is slower, their warmth steadier. These are the kinds of stars that live long enough to cradle planetary systems. It's okay to drift. A star like our sun glows with a temperature of about 5500 degrees Celsius at its surface, hot enough to shine but soft enough that from 150 million kilometers away, its light warms instead of burns. Imagine that warmth stretching through the dark for billions of years, keeping a small world vibrant, steady, and alive. You can rest now. As we drift deeper into the sea of starlight, we feel the texture of cosmic time shifting. We are no longer in the first age of stars, but in the era where galaxies begin to bloom. Each galaxy containing hundreds of billions of stars, each star carrying its own warm glow, its own slow rhythm, its own ancient story. A gentle quote rises from the quiet. Every star is a distant ember of the same fire that shapes you. You breathe softly, and the universe exhales through you. The Milky Way itself grew from these early clouds. Around its center, stars orbit at speeds near 220 kilometers per second, tracing long, graceful loops over hundreds of millions of years. Yet from our quiet vantage point tonight, they appear still, suspended, glowing, with a calm that meets your breath at the same pace. It's okay to drift. Some stars gather in clusters, tight families of light, where thousands of stars are born in the same cradle of gas and dust. A cluster may span only a few dozen light years, a tiny island in a galactic sea. But in that island, blue-white giants, soft yellow suns, and tiny red dwarfs shine side by side. Their combined light forms a gentle mist across the sky, like powdered gold drifting on a breeze. You can rest now. We watch as a red dwarf flickers softly. These stars, small and quiet, make up nearly 75% of all the stars in the universe. They shine faintly, coolly, often glowing, no brighter than a quiet ember. Yet they live for trillions of years, far longer than any other kind of star. If the universe were a vast library, red dwarfs would be the patient volumes that stay open long after others fade. Somewhere, light continues to travel. The first warm glow expands as we drift farther. Nebulae brush across our senses, soft clouds of dust and gas, where new stars begin to form. These clouds may stretch for hundreds of light years, painted with gentle red and blue emissions from young stars hidden within. And in these clouds, somewhere, a star is taking its first breath. You breathe softly, and the universe exhales through you. Fusion deepens, light strengthens. A small core warms to tens of millions of degrees. A surface forms glowing with its first steady color. It could be yellow like our sun, blue like hotter stars, or red like cooler ones. Each color is a temperature. Each temperature is a story. It's okay to drift. A young star may take 50 million years to settle into its stable glow, but once it does, it becomes one of the calmest, most reliable sources of light in the universe. For billions of years, it shines in perfect balance, gravity pulling inward, fusion pushing outward, like a breath held in cosmic stillness. You can rest now. As the first warm glow spreads through the galaxies, we drift near a star's surface, not close enough to burn, but close enough to feel the radiance soften. Our thoughts, like warm hands, smoothing creases from a blanket. A star's surface may appear turbulent, but from our distance, the motion is serene. Waves of plasma rise and fall in slow rolling patterns. Each wave spans thousands of kilometers, yet moves with a calmness that feels like the tide of a dream. You breathe softly, and the universe exhales through you. In the far distance, a supergiant glows with a diameter nearly 1,000 times larger than the Sunday. Its light is soft but enormous, a lantern hanging over a cosmic plane. Even though its mass is only a few dozen times larger, its swelling atmosphere creates a warm, dim radiance that feels like the slow pulse of an ancient heart. It's okay to drift. We drift farther, still seeing the universe as a tapestry of warm glows. Young stars, old stars, giants, dwarfs, clusters, and solitary lanterns in the dark. All of them shining because hydrogen learns to merge with hydrogen. All of them offering warmth, born from the simplest of elements. A soft thought folds into place. The atoms that burn in stars are the atoms that someday become life. In this way, a star's warm glow is not only light, it is a promise. You can rest now. Somewhere below the quiet, a star begins to fade. Its hydrogen thinning, its core cooling. But even as it dims, the light remains gentle, traveling across millions of years to reach wherever you are tonight. The universe keeps no distance from the quiet you hold. In the quiet between stars, you are remembered. The first warm glow becomes 1,000 glows, then 1,000,000, then billions. Every galaxy, every cluster, every drifting lane of light woven through the dark blooms from the same ancient warmth. This is the cosmos at rest. This is the universe breathing with you. This is the gentle path into sleep. You breathe softly, and the universe exhales through you. The warm glow stays with you as the story turns toward the next calm step. How stars grow age and drift through their long, patient lifetimes. Each phase opening into the next, like the slow petals of a cosmic flower. Light still travels, and you drift with it. The quiet from before lingers as we drift gently into the next soft chapter of starlight. The first warm glow has settled behind us like an ember carried in the palm of the universe. Now we move toward the slow bloom of a star, a moment not of sparks or noise, but of patience, stretching across millions of years. You can rest now. We drift together in a calm, dark cradle where a young star is learning its shape. Not quite bright yet, not quite steady, more like a warm pulse, beneath layers of drifting hydrogen gathering itself with a softness that feels almost alive. The universe holds this glow the way a quiet room holds a candle carefully, gently, with enough space for everything around it to breathe. You breathe softly, and the universe exhales through you. The young star contracts slowly under its own weight. Gravity draws the gas inward. Fusion in the core steadies aligning into a rhythm that will last for billions of years. This balance gravity, pulling in fusion, pushing out, is what relaxing science calls hydrostatic equilibrium. Though tonight, it simply feels like the steady heartbeat of a world being born. It's okay to drift. Inside the star, hydrogen fuses into helium at unimaginable speeds. 600 million tons of hydrogen becoming helium every second in a star like our Sunday. Yet from the quiet distance where we float, the process feels weightless, like a slow glow, gently expanding into the dark. Stars spend almost 90% of their lives in this calm equilibrium. This long, stable era is called the main sequence, though in our story, it is simply the bloom, the moment a star becomes itself. You can rest now. The light rising from the star's core begins a long journey upward. It might surprise you to know that a photon of light can take 1,000,000 years to escape from inside a star before it reaches space. Not because of distance, but because it keeps being absorbed and re-emitted, passed along like a whisper across billions of atoms. Somewhere, light continues to travel. When that photon finally reaches the star's surface and bursts outward, it travels through space at 3,000,000 kilometers per second, fast enough to circle Earth 7 times in a single heartbeat. Yet from where we drift tonight, the burst feels soft, like a sigh released after a long, patient wait. It's okay to drift. The color of the star deepens as the bloom stabilizes. Cooler stars glow red. Warmer stars glow yellow. Hotter stars shine blue-white. A red dwarf might surface at just 3,000 degrees Celsius, while a hot blue giant can burn at over 3,000 degrees. But here in the quiet, every color softens into a gentle warmth. You can rest now. We drift past a region of the star's surface, where patterns of granulation flicker like golden petals. Each granule is a rising column of hot plasma, thousands of kilometers across. From afar, they shimmer like the surface of a glowing lantern. Up close, they move with the slow rhythm of a tide. You breathe softly, and the universe exhales through you. A soft quote floats into the stillness. Light blooms slowly, but when it arrives, it fills everything. We drift around the star, following its steady glow as it matures. Its light spreads gently through the nebula where it was born. Dust grains shimmer. Gas clouds blush faintly in reds and blues as photons kiss their surfaces. Each color is a story of temperature, energy, and the quiet patience of atomic transitions. A cloud may glow red from hydrogen emissions, blue from scattered starlight, gold from a mix of dust and gentle heat. It's okay to drift. A young star often clears a path around itself, forming a cavity in the nebula. The radiation creates a safe pocket, a warm hollow where starlight breathes freely. Inside this hollow, dust grains begin to gather into rings, and somewhere in those rings, a planet may begin to form. You can rest now. The slow bloom of a star is also the slow bloom of future worlds. Dust particles collide and stick. Tiny grains become pebbles. Pebbles become stones. Stones merge into planetesimals, objects dozens of kilometers across. Over tens of millions of years, these world seeds collide and reshape themselves into spheres. We drift past one such forming world, wrapped in a haze of gas and dust. It shines faintly with the reflected light of its star, a soft echo of the bloom that gave it life. You breathe softly, and the universe exhales through you. The star behind it burns steadily, its brightness barely shifting even across millions of years. This stability is one of the most comforting truths in relaxing science. Stars like our Sun vary by less than 0.1% over centuries. Their consistency is a cosmic heartbeat, slow and reliable. It's okay to drift. As the star's bloom strengthens its magnetic fields, twist and coil, dark spots appear cooler regions called sunspots, but from our view, they look like gentle dimples on a glowing orb. Solar flares arc outward in enormous loops, sometimes stretching 1,000,000 kilometers high. Yet even these behave like quiet curls of light from where we watch. You can rest now. We glide toward a cluster of stars blooming together. A cluster may contain a few dozen stars, or tens of thousands. The Pleiades, for instance, are a group of hot blue stars 440 light-years away, glowing with the soft dust of their birth cloud. They appear to us like a handful of silver petals scattered on a dark river. The slow bloom is never solitary. Stars grow in families. You breathe softly, and the universe exhales through you. Gravity binds the cluster. Light weaves through it. Stars dance around a common center, each following an orbit that may take 100 million years to complete. Yet their motion feels still, suspended, as if time slows to the rhythm of the quiet. In the quiet between stars, you are remembered. We drift now toward a giant star, blooming at a scale beyond imagination. A blue giant shines with a luminosity up to 1,000,000 times brighter than the Sunday. But it burns through its fuel quickly, living only a few million years. Its bloom is brilliant, but brief, the cosmic equivalent of a deep inhale held for just a moment. It's okay to drift, but small stars burn differently. A red dwarf may shine at just 0.1% of the sun's brightness, but it can live for trillions of years. Their bloom is quiet, steady, and nearly eternal compared to the universe as we know it. Even long after our galaxy has changed shape, red dwarfs will still be glowing like tiny embers in the dark. You can rest now. The slow bloom of a star is not just brightness expanding into the night. It is warmth settling across the pillars of gas that cradle it. It is the quiet erosion of darkness by light. It is the soft shaping of space into a home for future worlds. Somewhere light continues to travel. We drift past filaments of plasma, twisting above the star's surface. They move slowly, gracefully, like ribbons of molten gold, drifting in a gentle current. At full scale, each filament may span 5,000,000 kilometers, but their motion is so calm, so deliberate, they appear like silk threads hanging in still air. You breathe softly, and the universe exhales through you. Farther out, solar wind pours gently into space, a stream of charged particles drifting outward at 400 kilometers per second, yet so thin, so delicate, it would pass through your outstretched hand without stirring a single grain of dust. It's okay to drift. In the surrounding space, dust grains shimmer. The star's light warms them to temperatures of just 2050 Kelvin in deep space, barely above absolute zero, yet enough for them to glow faintly in infrared light, like whispers of warmth carried through the dark. You can rest now. Another quote drifts into consciousness. Every warm glow is a beginning stretched across time. We drift into the star's habitable zone, the gentle region where warmth gathers just enough for worlds to hold liquid water. Around a sun-like star, this zone lies between 0.95 and 1.4 AU, a soft ring of possibility. Inside it, planets may bloom with oceans. Outside it, ice forms in crystalline layers, reflecting the glow back into space. You breathe softly, and the universe exhales through you. The slow bloom continues for billions of years. Light remains steady, warmth remains patient. Stars like this can live for 10 billion years, holding their glow with the gentleness of a lantern in a long night. It's okay to drift. Eventually, a star like ours will grow brighter by about 10% every billion years. This slow increase is the gradual unfolding of its bloom, a natural part of its aging. But from the perspective of life, these changes are so slow, they feel like the universe whispering rather than shifting. You can rest now. We drift away from the star, letting its warm glow shrink into a soft golden point against the dark. Around us, billions of other stars bloom at their own paces, some fast, some slow, some bright, some faint. Each one a quiet story of hydrogen learning to shine. In the quiet between stars, you are remembered. The slow bloom of a star is not a moment in time. It is a presence, a warmth, a steady breath the universe holds for ages. And as we move toward the next chapter of this journey, the glow follows us like a calm promise. Light still travels, and you drift with it. The glow behind us softens as we drift farther into the calm span of a star's long, steady life. The bloom has settled. The warmth has reached balance. Now the universe opens into the quiet middle chapters, the long seasons of starlight, where nothing seems to rush and everything simply continues. You can rest now. A star in its quiet middle age is a creature of patience. It doesn't flicker. It doesn't flare with urgency. It holds its brightness like a slow breath, repeating the same ancient rhythm across billions of years. From our soft vantage point, it feels less like an object and more like a presence, a warm lantern in the dark. You breathe softly, and the universe exhales through you. You can rest now. Eventually, a star like ours will grow brighter by about 10% every billion years. This slow increase is the gradual unfolding of its bloom, a natural part of its aging. But from the perspective of life, these changes are so slow, they feel like the universe whispering rather than shifting. A star like our sun is about 4.6 billion years into its life. It's halfway through the steady process of turning hydrogen into helium, one gentle fusion at a time. At the center, pressure climbs to 250 billion atmospheres. Yet the star expresses none of that strain. It simply shines. It's okay to drift. Photons emerge from the surface of the star in a slow golden rain. They drift outward through space, spreading thinner and softer as distance grows. Some will travel 10 trillion kilometers before touching anything. Some will journey across the galaxy for 1,000,000 years before brushing the dust of a nebula. Some will wander for billions of years until they find an eye, a leaf, a world. Somewhere, light continues to travel. The surface of a calm star rolls with convection, great cells of rising and falling plasma, like a pot of warm water simmering slowly. Each cell may span 3,000 kilometers, yet moves so gently that from afar it appears almost still. The quiet of stellar time makes even the most massive motions feel soft. You can rest now. Magnetic fields twist in wide arcs above the star. Loops of glowing plasma climb into the dark, forming structures taller than Earth's diameter. But from our drifting perspective, they seem like strands of silk suspended in a slow breeze. You breathe softly, and the universe exhales through you. A soft quote folds into place. Even the brightest fires have quiet hearts. We move outward, letting the star shrink to a golden coin, suspended against the dark. Across this calm region of space, countless stars share the same quiet middle age. Their light mingles, forming a soft haze, a glow made not of any single star, but the collective warmth of millions. It's okay to drift. Farther out, we pass a binary system, two stars in a slow, deliberate dance. They orbit one another at a distance of tens of millions of kilometers, completing a full rotation every few days or every few centuries, depending on their mass. To us, they look like two fireflies orbiting a shared center, their glows blending and parting with each slow turn. You can rest now. Most stars, nearly half of those in the Milky Way, exist in multiple star systems. Some pairs orbit closely, tugging each other into tight elliptical loops. Others drift far apart, connected only by the gentle pull of gravity. From our quiet vantage, each pair feels like a relationship written in light. In the quiet between stars, you are remembered. We drift farther inward toward the galactic plane, where starlight thickens like dust motes in a sunbeam. A yellow star burns softly beneath us, no larger than the sun, but surrounded by a halo of faint shimmering dust. This dust glows faintly in infrared, warmed to just 4080 Kelvin, barely above absolute zero. Yet it radiates like a soft memory. You breathe softly, and the universe exhales through you. This dust, born from older stars, will someday form new worlds. Inside each grain lies oxygen, silicon, carbon, tiny seeds, waiting for gravity to gather them. A star's quiet middle age is not merely a pause. It is a long preparation for what will come after. It's okay to drift. We drift farther inward toward the galactic plane, where starlight thickens like dust motes in a sunbeam. A yellow star burns softly beneath us, no larger than the sun, but surrounded by a halo of faint shimmering dust. This dust glows faintly in infrared, warmed to just 4080 Kelvin, barely above absolute zero. Yet it radiates like a soft memory. You breathe softly, and the universe exhales through you. We slide toward a cluster of ancient stars, a globular cluster glowing like a suspended globe of silver dust. Some clusters contain hundreds of thousands of stars packed within just 100 light years. Many are older than the Milky Way itself, reaching ages of 12 billion years or more. Somewhere light continues to travel. This dust, born from older stars, will someday form new worlds. Inside each grain lies oxygen, silicon, carbon, tiny seeds, waiting for gravity to gather them. A star's quiet middle age is not merely a pause. It is a long preparation for what will come after. You breathe softly, and the universe exhales through you. Around such a star, planets may exist, but they are simple worlds: rock, ice, and thin atmospheres. Life, if it ever arose, would have faced long eras of quiet starlight, billions of years, with almost no change, no shifts, no urgency. It's okay to drift. The long quiet of stellar time stretches across the galaxy like a slow wave. Most stars spend their lives here, steady, patient content in the equilibrium between gravity and fusion. This phase can last for billions, sometimes trillions of years. You can rest now. We drift toward a region of space near a supergiant star. Though the supergiant is bright, the universe around it remains calm. Its outer layers shimmer, gently expanding and contracting in cycles that may last hundreds of days. Each breath of expansion cools the surface slightly. Each contraction warms it again. The star breathes at a pace slower than thought. In the quiet between stars, you are remembered. We continue drifting, letting time stretch thin like silk. A middle-aged star grows slowly more luminous, its fusion rate rising as helium accumulates in the core. Inside, temperatures climb toward 100 million degrees, though nothing outside reveals this growing tension. The universe hides its changes beneath calm faces. You can rest now. The long quiet teaches something essential about stars, that brilliance doesn't require haste. Most of their light comes not from sudden reactions or violent events, but from the consistent merging of tiny particles one by one over billions of years. Somewhere, light continues to travel. We drift out of the plane of the galaxy, rising above the spiral arms, until the disk glows beneath us like a soft river of gold. Here, stars are sparser, but their light is no less warm. Thin streams of older stars form tidal traces, ghostly arcs created by long-ago collisions between galaxies. These faint rivers of light hold stars that have drifted for billions of years, never rushing, never fading quickly. You breathe softly, and the universe exhales through you. The long quiet is not emptiness. It is abundance, spread thin. It is the spaciousness of time, measured not in years, but in cycles of fusion rotation and slow drift. A star may spin once every 25 days at its equator, or once every 100 days depending on age and temperature. These rotations mark time the way tides mark shores. It's okay to drift. We float past a star with a wide, habitable zone. Temperatures remain stable across billions of years, creating a cradle where life could thrive. If a world orbits in this zone, light touches it with just the right warmth for water to remain fluid. Some of these worlds may be ocean planets, global seas, stretching thousands of kilometers deep. You can rest now. The quiet of stellar time nurtures such worlds. Life, if it appears, may take millions of years to awaken, but stars offer the patience it needs. A main sequence star is like a caretaker of time itself, offering stability on scales that life can depend on. In the quiet between stars, you are remembered. We drift now toward the end of the long quiet. Not the final glow, not yet, but the subtle shift that comes when hydrogen grows thin, when the star's core contracts and its outer layers begin to warm. The long quiet begins to tremble, not with fear, but with preparation. You can rest now. All around us, stars at this threshold glow slightly brighter. Their surface is warmed by 10–20% over hundreds of millions of years. It is the gentle turn of the stellar tide, the moment just before a star begins to swell into a red giant. Somewhere, light continues to travel. The universe prepares for another transformation, the slow unfolding of the giant phase, the reddening of starlight, the soft expansion of outer layers that drift like petals unfurling in warm wind. We drift with them, feeling the future glow, forming like a memory ahead of us. You breathe softly, and the universe exhales through you. The long quiet of stellar time comes to a close, not with a sound, not with a flash, but with a soft shift in temperature, a whisper that the star is ready for its next chapter, a chapter of deeper light, wider forms, and blooming color. Light still travels, and you drift with it. The quiet that carried us through the long calm of stellar time softens now like a warm curtain slowly lifting. A star, after billions of years of steady breath, begins to change. Not suddenly, not loudly, but with the same patience. It has always held a patience shaped by fusion gravity and the deep rhythm of the universe. You can rest now. The star's core contracts with a slow inevitability. Hydrogen is nearly gone at the center, though a shell of it remains around the core. As the core tightens, it grows hotter, not by a little, but by millions of degrees. Yet, from the outside, everything remains calm. The surface warms, the glow deepens. A soft blush spreads across its bright face. You breathe softly, and the universe exhales through you. A gentle fact drifts into place. When a star, like our sun, begins moving toward its red giant phase, its diameter expands first by a few percent, then by tens of percent, and eventually by more than 100 times its original size. This swelling happens over hundreds of millions of years, slow enough to match even the longest breaths of cosmic time. It's okay to drift. The outer layers of the star loosen. Gravity no longer holds them as tightly as before. They ripple outward, like fabric warming in sunlight. Convection becomes more pronounced. Hot gas rises from deep within, cools at the surface, then sinks again. A soft, eternal cycle, like the turning of a tide. You can rest now. As the star expands, its surface cools. Where once it blazed at 5500 degrees Celsius, it now glows at 30004000 degrees, shifting from gold to amber to deep red. This is what gives the red giant its name. A warm, gentle radiance, born from a larger, cooler surface. Somewhere light continues to travel. We drift closer to the star's surface, and the scale becomes unbelievable. A granule on a dwarf star, like the sun, might be 1000 kilometers across. But on a red giant, a single granule can exceed 100000 kilometers, large enough to swallow entire worlds. Yet their motion is slow, calm, rolling, like continents of glowing plasma, sliding across an endless shore. You breathe softly, and the universe exhales through you. The atmosphere around the red giant thickens into halos of shimmering dust. Tiny grains of carbon and silicates drift outward. Some escape into space. Some fall back into the star. Some gather into wide rings, the beginnings of future nebulae. It's okay to drift. A poetic line rises through the quiet. Every star grows old by learning to shine in warmer colors. The inner shell of hydrogen burning around the core releases enormous energy. This energy pushes the outer layers farther outward. The star becomes luminous sometimes, 1000 times brighter than before. But brightness from where we drift does not feel harsh. It feels mellow, ancient, like a lantern stretched thin. You can rest now. We drift around the star, following its vast surface through delicate folds of light. Dark patches appear not sunspots in the usual sense, but cooler pockets, forming where convection weakens. These regions look like shadows cast by the star's own breath. They move slowly over months or years, never in a hurry. In the quiet between stars, you are remembered. A red giant may swell so large that if placed where our sun is now, it could reach the orbit of Mercury or Venus or even Earth. The numbers are immense, but the feeling here is gentle, an old star stretching into a softer shape. You breathe softly, and the universe exhales through you. Inside the core, the contraction continues until helium begins to fuse. But helium requires far more heat, around 100 million degrees. Until that moment arrives, the core tightens, compressing like a deep inhale held for eons. It's okay to drift. When helium fusion finally ignites in a sun-like star, it does so with extraordinary suddenness, a flash that lasts only minutes. Yet this event is hidden beneath layers of dense plasma, never reaching the surface, never disturbing the calm bloom of the red giant. From our drifting perspective, nothing changes but the glow, a little steadier, a little warmer, a little more serene. You can rest now. With helium now burning in the core, the star finds a new balance. Its expansion slows. Its brightness stabilizes. It glows with a dignified warmth, as though it has entered a quiet autumn of starlight. Somewhere light continues to travel. We drift farther out, seeing the star as planets would see it. Any inner worlds would now be lost, swallowed by the star's widening atmosphere. But outer planets, cooler, slower, may still orbit, bathed in a deeper, redder light. Their skies would glow with permanent sunset, soft and dim, washing everything in amber. You breathe softly, and the universe exhales through you. On such worlds, daytime would feel like dusk. Shadows would stretch long across the ground. Colors would soften. Ice on distant moons might begin to melt under the increased warmth. Frozen oceans could awaken. Atmospheres could thicken. It's okay to drift. Dust, formed in the outer layers of the red giant, drifts outwards. These grains may survive for billions of years, carrying within them the elements forged during the star's life: carbon from helium burning oxygen, from fusion shells, iron from deeper processes. You can rest now. This dust becomes the raw material for new stars, new planets, new chemistry, new life. Every molecule of carbon in your body was once part of a red giant's breath. In the quiet between stars, you are remembered. We glide along the red giant's edge, watching its light shimmer across enormous loops of plasma. These loops, called prominences, can stretch 10, 20 times the size of Earth, curling outward like molten wings. Their motion is slow enough to feel hypnotic, a choreography written in magnetism and heat. You breathe softly, and the universe exhales through you. The star pulses, not in seconds but in cycles of months or years. Its outer layers expand and contract, like a chest rising in slow motion breathing. Some red giants vary in brightness by 20–30%, their light waxing and waning through patterns older than human time. It's okay to drift. We drift through a thin shell of gas carried outward by the star's wind. Red giants shed mass at a rate millions of times stronger than dwarf stars, creating winds that drift at 1040 kilometers per second, carrying the star's outer layers into the galaxy. Yet, the wind is gentle, thin, like drifting powder. You can rest now. A soft quote drifts across the silence. A dying star is merely whispering its light back into the dark. We glide deeper into the expanding envelope, seeing swirling layers like gauze floating on warm air. Each layer represents a different era in the star's retreat from its younger form. Some are enriched with carbon, some with oxygen, some with heavier elements forged in its warming belly, somewhere light continues to travel. In time, these layers will detach completely, forming a planetary nebula, a glowing shell surrounding the star's shrinking core. But that moment lies ahead. Not here, not yet. For now, the red giant continues its slow, dignified bloom. A bloom that lasts 100 million years. A bloom filled with warmth and memory. A bloom rich with the potential for new worlds. You breathe softly, and the universe exhales through you. The star's outer layers begin to ripple with instability. Heavier elements sink, lighter elements rise. Convection deepens, stirring the star like a simmering ocean. We watch continents of plasma shift and dissolve, illuminated by soft red light. It's okay to drift. The helium in the core will eventually run out just as hydrogen once did. When that moment comes, the star will move into its final flowering, a beautiful, brief, expanding glow that carries the last of its warmth outward. But for now, we stay here, in the gentle rise of the red giant, where light is warm and slow, and time moves with the softness of breath. You can rest now. The glow deepens as we drift away, leaving behind petals of red light spreading into the dark. Ahead lies the final bloom, the nebula, the white dwarf, the quiet end of a star's long journey. Light still travels, and you drift with it. The gentle red glow behind us softens into a warm memory as we drift farther into the star's final flowering. The red giant has expanded, breathed, slowly released its dust, and warmed distant worlds. Now, it stands at the threshold where a star begins to loosen its hold on itself and prepares to let its light drift back into the dark. You can rest now. The core, small and intensely hot, has burned through its helium. No new fuel remains to balance gravity from within. The inner regions tighten. The outer layers respond by swelling outward in slow rhythmic waves, soft expansions that continue for tens of thousands of years. You breathe softly, and the universe exhales through you. Each expansion pushes a thin shell of gas into space. These shells drift outward at 10-20 kilometers per second, forming expanding halos that cool and shimmer. Layer after layer falls away, each one carrying the memory of an earlier era in the star's life. It's okay to drift. We drift close to the unfolding glow. The gas is thin, so thin you could travel through it without disturbing a single atom. Yet from a distance it shines with soft color. Red from hydrogen, green and blue from oxygen, purple from nitrogen. This is the birth of a planetary nebula, a misnamed phenomenon that has nothing to do with planets and everything to do with the last bloom of starlight. You can rest now. A planetary nebula may span 1 light year, a fragile bubble of light formed from the star's outer layers. Inside the core contracts into something small, white-hot and fierce, a white dwarf. But the nebula surrounding it is delicate, like frost on the surface of a soap bubble. Somewhere, light continues to travel. We drift along the expanding shell. Filaments twist into spirals. Wisps curl like threads of silk. Shock waves from earlier pulses intersect with newer ones, creating ripples of brightness that move outward in slow motion patterns. What we see as glowing shapes are merely atoms excited by the star's ultraviolet light. A final gesture of illumination. You breathe softly, and the universe exhales through you. The planetary nebula is brief by cosmic standards. It lasts only 1,000,002,0000 years before fading into the dark. A short, beautiful bloom, the cosmic equivalent of a flower opening at dusk and closing before dawn. It's okay to drift. Inside the nebula, the temperature of the core climbs above 1,000,000 degrees Celsius, hot enough to strip electrons from surrounding gas, causing it to glow in vibrant colors. The luminous rings and petals we see in telescopes are photons released from atoms returning to calm after excitation light returning home. You can rest now. A quote folds into the quiet. Every ending is a lantern held up to remind the universe how bright it once was. We move around the nebula's outer edge, watching knots of dust form small, dense beads, structures just a few billion kilometers across. These knots survive long after the nebula fades. They drift through the galaxy as seeds for new stars. In the quiet between stars, you are remembered. The white-hot core at the center is shrinking into a white dwarf. Its size is astonishing, roughly the same as Earth, yet containing half the mass of the Sunday. A spoonful of its matter would weigh millions of tons on Earth. But from where we drift, it appears as a small bead of radiant light, softened by distance and the glow of the nebula around it. You breathe softly, and the universe exhales through you. As the nebula expands, its colors stretch and fade. Oxygen glows blue-green. Hydrogen glows soft red. Nitrogen glows violet. The patterns resemble petals, wings, shells, halos, shapes, sculpted by magnetic fields and stellar winds. It's okay to drift. Some nebulae take on symmetric forms, two lobes on opposite sides like lanterns placed back to back. Others form spirals, their shapes traced by unseen companion, stars orbiting the dying giant. A few become glowing rings, perfect circles of color opening in the dark. You can rest now. We drift through one such ring, the gas so thin it barely brushes our presence. The interior glows softly, where ultraviolet light energizes the gas. The outer edges fade into cool darkness. From certain angles, the nebula resembles an eye, a quiet, cosmic eye watching the centuries pass. Somewhere light continues to travel. The white dwarf at the center pulses faintly in brightness, not from activity, but from the release of residual heat. Surface temperatures may reach 1,000,000 Kelvin. Yet the dwarf is so small that its light radiates, freely illuminating the nebula from within. You breathe softly, and the universe exhales through you. Over thousands of years, the nebula expands and thins. Its colors fade. its edges dissolve. It becomes a faint whisper of its former shape, a memory drifting outward in all directions. It's okay to drift. The dust formed during the red giant phase now moves independently, cooling into tiny grains of carbon and silicate. Some of these grains will join molecular clouds, vast nurseries where new stars are born. Others will wander alone through the galaxy, waiting for gravity to gather them once more. You can rest now. A soft truth settles into place. Planetary nebulae are the universe recycling itself. Stars bloom, fade, and shed their layers only to provide the ingredients for future light. The oxygen you breathe, the carbon in your cells, the calcium in your bones, all were once lifted gently from the envelope of a red giant, carried into space, and woven into something new. In the quiet between stars, you are remembered. The nebula before us dissipates further. Its colors dim, its filaments lose definition. Soon it will disappear entirely, leaving only the white dwarf behind, cooling slowly over billions of years. You breathe softly, and the universe exhales through you. White dwarfs are steady beacons for long ages. They cool gradually, first bright as raw embers, then dim as old coals, eventually becoming black dwarfs after potentially trillions of years. No universe we know has existed long enough for one to fully cool. It's okay to drift. We drift above the fading nebula, watching as one last ribbon of gas catches the starlight, glows softly, and dissolves into the dark. No sound, no rush, just a final shimmer before merging with the emptiness. You can rest now. A final poetic line closes this bloom. The star is gone, but its light has already chosen its next home. Ahead of us, the galaxy stretches in soft spirals, each arm filled with new stars, forming from old dust, each cluster rising from the remains of predecessors, each nebula glowing with borrowed light. Somewhere light continues to travel. We drift forward into regions where newborn stars stir within their dark cocoons. The next chapter, waiting gentle as breath, ancient as hydrogen, bright as beginnings. You breathe softly, and the universe exhales through you. Light still travels, and you drift with it. The last bloom of the nebula fades behind us like a dissolving memory, soft colors drifting into the darkness until they become part of the night again. What remains at the center is small, brilliant, and impossibly dense, a white dwarf cooling slowly in the dark. You can rest now. A white dwarf is not large like the star that made it. It is only about the size of Earth, yet it holds nearly half the mass of the Sunday. Its gravity is fierce, its surface hotter than anything we have seen so far, glowing at 1,000,000 Kelvin just after formation, though it will cool as the millennia pass. You breathe softly, and the universe exhales through you. The quiet ember radiates pure, steady light. Not through fusion, that process is over, but through residual heat, slowly escaping from its dense interior. The atoms inside are packed so tightly that a teaspoon of this material would weigh millions of tons on Earth. It's okay to drift. We float near the surface, and the glow feels different from the warmth of main sequence stars. This light is thinner, more delicate, almost crystalline. No turbulence ripples across the surface. No convection sends waves upward. White dwarfs are calm, completely calm, held together by what relaxing science calls electron degeneracy pressure. But tonight, we don't need the term. We only need the quiet. You can rest now. This white dwarf will cool for billions of years, slowly, steadily, gracefully. Its color will shift from bright white to soft yellow, then to warm orange, then to quiet red, and finally to a gentle darkness beyond red. Somewhere, light continues to travel. Around it, the remnants of the old nebula continue drifting outward fainter with every passing century. Dust grains cool to just a few tens of Kelvin. Gas thins until it is practically indistinguishable from space. Eventually, the nebula dissolves completely, leaving only emptiness around the white dwarf, a silent reminder of the star that once bloomed so brightly. You breathe softly, and the universe exhales through you. White dwarfs rotate slowly, sometimes taking hours, sometimes days, rarely longer. Their magnetic fields can be thousands of times stronger than Earth's, yet from afar they seem serene, their glow unwavering. It's okay to drift. In binary systems, white dwarfs may continue interacting with companion stars, drawing small streams of gas from a nearby red giant or main sequence star. These streams spiral inward, forming glowing disks of matter that rotate at astonishing speed. But even this drama appears soft from our distance, a thin ring of pale light glowing around a quiet ember. You can rest now. We drift farther out, watching the white dwarf shrink into a tiny pearl. Over time, over immense time, it will dim into a black dwarf, a cold sphere of carbon and oxygen, holding the silence of all the light it once gave. It's okay to drift. In the quiet between stars, you are remembered. A soft quote settles across the silence. Even an ember remembers the fire that shaped it. We drift toward another remnant, not a white dwarf, but a neutron star born from a heavier star's collapse. Its diameter is only 20 kilometers, yet it contains more mass than the Sunday. Its density is unimaginable. Its gravity is intense. But from here, from the safe, quiet, where we hover, it looks like a tiny, unwavering bead of light. You breathe softly, and the universe exhales through you. This neutron star spins rapidly, perhaps hundreds of times per second, sending beams of radiation into space in regular pulses. Astronomers call them pulsars, but to us it feels like a cosmic heartbeat, a steady rhythmic flicker echoing across the dark. It's okay to drift. This neutron star spins rapidly, perhaps hundreds of times per second, sending beams of radiation into space in regular pulses. Astronomers call them pulsars, but to us it feels like a cosmic heartbeat, a steady rhythmic flicker echoing across the dark. You can rest now. It's okay to drift. Somewhere light continues to travel. Around some black holes, accretion disks form wide, swirling rings of gas, shining brightly as they spiral inward. Temperatures in these disks can reach millions of degrees, lighting the dark with intense X-rays. But as we watch from afar, all of this appears muted, like a lantern behind layers of fog. Somewhere light continues to travel. We drift back toward calmer remnants, white dwarfs, cooling stars, faint embers scattered across the galactic plane, millions of them, maybe billions, each holding the final warmth of a star that lived and shone for ages. It's okay to drift. These remnants are not lonely. They are part of a cycle. Dust from old stars gathers into new clouds. New clouds collapse into new cores. New cores ignite into new stars. This process has repeated for 13.8 billion years and will continue long after we are gone. You can rest now. The quiet ember of a dying star is the universe telling us that even endings are gentle, that nothing disappears. It simply cools, changes shape, and returns to the cosmic ocean. In the quiet between stars, you are remembered. We drift one last time around the cooling white dwarf, its glow soft, its surface calm, its light steady. It has no more fuel, no more volcanic fusion within, only stored heat slowly fading through the long night. You breathe softly, and the universe exhales through you. As the dwarf cools, its crystalline core may begin to solidify. Carbon may freeze into a lattice. Oxygen may settle into rigid structures. In time, immense time, the white dwarf becomes a giant diamond in the dark, a cosmic jewel forged from the heart of a star. It's okay to drift. The galaxy around us glows faintly with distant suns. Clusters shimmer like scattered grains of gold. Nebulae stretch across the shadows. And here, this small ember glows with the memory of a life well lived. You can rest now. We drift away, letting the cooling star fall behind us, shrinking to a spark, then to a point, then to darkness. Ahead, new stars wait to be born from dust and silence. New light prepares to rise. New chapters unfold in the slow pulse of cosmic time. Somewhere, light continues to travel. You breathe softly, and the universe exhales through you. Light still moves, and you drift with it. The ember behind us fades to a gentle memory as we drift farther into the dark between stars. It is quiet here, the soft, ancient quiet of a galaxy catching its breath. But in this stillness, something begins to gather, something faint, something cool, something waiting. You can rest now. Every star that has lived and died has left something behind, dust gas atoms forged in its heart, scattered into the galaxy like pages from a long, slow story. This material drifts for millions of years, carried by gentle winds, shaped by gravity, lit by distant suns. You breathe softly, and the universe exhales through you. We drift into one such region now, a molecular cloud stretching hundreds of light years across. It appears dark, from the outside, opaque, to starlight, a cold shadow against the brighter Milky Way. Temperatures inside dip as low as 10 Kelvin, so cold that molecules cling together like grains of frost. It's okay to drift. This darkness is not emptiness. It is shelter. It is potential. It is dust and gas, waiting for gravity to whisper them inward. Over millions of years, small fluctuations grow. Bits of hydrogen cluster. Columns of dust coalesce. A quiet gathering begins in the depth of the cloud. You can rest now. The richness of this dust holds the memory of billions of stars. Carbon from red giants, oxygen from massive supernovae iron, from the collapsed cores of suns that ended violently, all of it drifting together in silence, a soft inheritance that becomes the seed of new light. Somewhere light continues to travel. Inside the cloud, we drift past long filamentary structures, ribbons of gas, dozens of light years, long woven, like threads in a cosmic tapestry. Gravity gathers these threads, wraps them, tightens them, until small knots begin to appear along their lengths. These knots are called cores, and in each core, a star will someday awaken. In the quiet between stars, you are remembered. It's okay to drift. Inside the cloud, we drift past long filamentary structures, ribbons of gas, dozens of light years, long woven, like threads in a cosmic tapestry. Gravity gathers these threads, wraps them, tightens them, until small knots begin to appear along their lengths. You breathe softly, and the universe exhales through you. This object is called a protostar, a star still wrapped in its cocoon of dust. You can rest now. Protostars shine not from fusion, but from the heat of slow collapse. Gravity tightens, pressure rises, temperature builds. Over millions of years, the protostar grows denser and brighter, pulling more material from the cloud around it. Somewhere, light continues to travel. We drift deeper into the core, seeing swirling disks of dust form around the protostar. These disks may stretch for hundreds of billions of kilometers, thin as smoke at their edges, dense near the central glow. Planets begin here in small grains, colliding gently, clumping slowly into larger shapes. You breathe softly, and the universe exhales through you. You breathe softly, and the universe exhales through you. It's okay to drift. The protostar continues to collapse until its core temperature reaches several million degrees. At this threshold, hydrogen nuclei begin to fuse, not fully, not steadily, but in tentative reactions that mark the threshold between becoming and being. This is the first breath of starlight. You can rest now. Every time two grains touch, they stick with weak electric charges. A grain becomes a pebble becomes a stone becomes a world slowly building layer by layer in the soft half-darkness of a young stellar system. You can rest now. The surrounding cloud thins as the growing star's radiation warms the cavity around it. Jets of material erupt from the poles, thin beams of gas, traveling at hundreds of kilometers per second, carving channels through the dark. These jets are not violent. They are corrective. They help the star regulate its rotation and shed excess energy. You breathe softly, and the universe exhales through you. The disk around the young star begins to clear. Material finds stable orbits or falls inward. Gaps open in the dust as forming planets carve their paths. These gaps widen over millions of years, creating rings of cleared space, soft ripples in the architecture of a growing system. It's okay to drift. A gentle line rises into the silence. Every new star carries the dust of the ones that came before. We drift to one side where a planetesimal grows large enough to warm itself with radioactivity and impacts. Its interior melts, its surface smooths. It begins to pull smaller bodies inward. This world may never become Earth-like, but it will become something: a moon, a dwarf planet, a wandering world of ice, a building block for something greater. You can rest now. Meanwhile, the star strengthens. Its core reaches 10 million degrees, enough for stable hydrogen fusion to begin. The star stabilizes its brightness, adopting a steady glow that will last for billions of years. The Tatauri flickering fades. Convection calms. The star enters the main sequence, the long middle chapter of its life. These remnants are not lonely. They are part of a cycle. Dust from old stars gathers into new clouds. New clouds collapse into new cores. New cores ignite into new stars. This process has repeated for 13.8 billion years and will continue long after we are gone. Dust around the star begins to dissipate, pushed outward by stellar winds. This dust will join the interstellar medium, providing material for future stars. Some grains will drift for billions of years before finding a home in another cloud. You breathe softly, and the universe exhales through you. We drift farther out, seeing other stretched forms of star birth in every direction. Pillars of gas glowing at their edges, bright young stars illuminating the walls of their cradles, winds sculpting hollow cavities that open into new regions. Of the cloud, massive stars form faster in just a few million years, collapsing with intensity, quickly igniting into brilliant blue giants. But their lives are short. We leave them to their own chapters. It's okay to drift. Instead, we follow a smaller star, gentler, quieter, born from the cooling dust of ancestors. Its light feels familiar, like the promise of morning after a long night. Planets gather around it in slow arcs. Moons form from debris. Asteroid belts mark the boundaries between stability and chaos. You can rest now. As we move through the arm, young clusters glow in soft blues, their massive stars shining with a brightness that reaches tens of thousands of suns. These stars burn quickly, million-year lanterns. But their light is powerful enough to carve cavities in the surrounding gas, creating regions of glowing red hydrogen stretched across dozens of light years. In the quiet between stars, you are remembered. The molecular cloud that birthed these stars gradually disperses its dust, blown apart by radiation from the newborn systems. The region grows transparent. Starlight escapes. The once dark cloud becomes a glowing region, a nebula lit from within, colorful and soft in its final stage of dispersal. You breathe softly, and the universe exhales through you. We emerge from the cloud, looking back at its long filaments, its star-filled cavities, its slow collapse and quicker dispersal. The nebula glows with pinks from hydrogen blues, from scattered light gold, from dust warmed by young suns. It's okay to drift. A soft truth settles across the silence. The galaxy is filled with these cycles. Stars die and give their dust to the next generation. Dust collapses and gives rise to new stars. Light fades and returns again and again in a rhythm as old as time. You can rest now. We drift onward past young stars, beginning their long lives, past fading nebulae, losing their glow, past streams of dust, drifting into the spiral arms of the galaxy. Somewhere light continues to travel. Stars rise, stars bloom, stars fade, stars return as dust. Dust gathers, light returns, all of it written in slow, patient loops of creation. You breathe softly, and the universe exhales through you. The rebirth written in dust is not a story of endings or beginnings, but of continuity, a cosmic inheritance that passes through billions of hearts of fire. You breathe softly, and the universe exhales through you. You can rest now. When you look at a galaxy, you're seeing billions of stars sharing a vast, slow rhythm, each one moving under the pull of gravity, each one a note in a silent, ancient music. The Milky Way completes one full rotation every 230 million years, a motion so slow and smooth that even whole civilizations rise and fall without noticing its turn. The rebirth written in dust is not a story of endings or beginnings, but of continuity, a cosmic inheritance that passes through billions of hearts of fire. Light still travels, and you drift with it. The dust of rebirth drifts quietly behind us as we move deeper into the wide arms of the galaxy. Here, stars gather in patterns that look almost deliberate: streams, clusters, arcs, and long ribbons of pale glow. Light is not scattered randomly, it is woven, thread by thread, breath by breath, into the quiet fabric of the Milky Way. It's okay to drift. We drift into one of the spiral arms, a region where dust is thicker, gas is denser, and star formation ignites like sparks along a riverbank. These arms are not fixed structures, they are density waves, patterns of compression moving through the disk of the galaxy, subtle as tides. You can rest now. We drift through one such region, feeling its quiet intensity. The gas is warm, not like the heat of a star, but like the memory of warmth, long after a fire has burned. The light here is diffuse, soft edges blending into softer shadows. Somewhere, light continues to travel. A gentle fact rises with the glow. The Milky Way contains between 100 and 400 billion stars, and nearly all of them orbit the center at speeds near 220 kilometers per second. Yet from our drifting vantage, the galaxy appears still holding itself in a quiet shape of light. You breathe softly, and the universe exhales through you. We move toward a region where older stars gather yellow suns, orange giants, quiet red dwarfs glowing softly. They create a backdrop of warm light, a cosmic dusk that fills the galactic plane with gentle radiance. It's okay to drift. These old stars drift slowly outward from their birth clouds, carried by the rotation of the galaxy. They settle into wide orbits, some moving above or below the plane, creating a thick disk of light that envelops the spiral arms like a luminous blanket. You can rest now. Farther out, we encounter star streams, long trails of stars torn from smaller galaxies long ago. These streams stretch across tens of thousands of light years, thin, elegant arcs shaped by tidal forces. The stars within them share similar velocities, like dancers moving in the same slow pattern. In the quiet between stars, you are remembered. These old stars drift slowly outward from their birth clouds, carried by the rotation of the galaxy. They settle into wide orbits, some moving above or below the plane, creating a thick disk of light that envelops the spiral arms like a luminous blanket. We emerge from the cloud, looking back at its long filaments, its star-filled cavities, its slow collapse, and quicker dispersal. The nebula glows with pinks from hydrogen blues, from scattered light gold, from dust warmed by young suns. The galaxy continues weaving itself around us. Gas clouds drift into spiral arms. Shock waves compress them. Stars ignite. Winds clear cavities. Supernovae enrich the gas. Dust forms. Dust collapses again. The cycle repeats endlessly, each repetition adding a new thread to the fabric. It's okay to drift. Inside the cluster, the oldest stars still burn, red giants glowing like warm embers, white dwarfs shining like pale beads of crystal. Their light blends into a single golden haze like a city seen from far across a sleeping valley. You can rest now. It's okay to drift. Inside the cluster, the oldest stars still burn, red giants glowing like warm embers, white dwarfs shining like pale beads of crystal. Their light blends into a single golden haze like a city seen from far across a sleeping valley. We drift through the outskirts of the cluster. The density falls, stars thin, darkness deepens. The cluster's halo stretches out like a faint whisper of its former self-stars, slowly drifting away over billions of years. You breathe softly, and the universe exhales through you. We drift through the outskirts of the cluster. The density falls, stars thin, darkness deepens. The cluster's halo stretches out like a faint whisper of its former self-stars, slowly drifting away over billions of years. We drift back into the galactic disk. Dust lanes weave through the arms, dark against the brighter background. These lanes contain the raw material for future stars, cold hydrogen, carbon grains molecules, held together by the quiet of deep space. Inside the cluster, the oldest stars still burn, red giants glowing like warm embers, white dwarfs shining like pale beads of crystal. Their light blends into a single golden haze like a city seen from far across a sleeping valley. We pass a lane stretching for hundreds of light years. Along its edge, young stars illuminate the boundary, casting pale blue light that reflects off dust particles, creating faint streaks and halos. These glowing edges mark the places where gravity has begun its work. You can rest now. Supernova remnants appear next wispy shells, expanding outward at thousands of kilometers per second, soft ripples that carry heavy elements forged in the dying star's core. Iron, nickel, cobalt, gold, all drifting outward to blend with the interstellar medium and join the next cycle of creation. In the quiet between stars, you are remembered. We drift past one such remnant. Its edges glow in red, its interior filled with faint blue haze. The explosion that created it would have outshone entire galaxies for a brief moment, but now it is quieter than a sigh, a delicate bubble dissolving slowly into the dark. You breathe softly, and the universe exhales through you. Closer to the galactic center, stars grow denser. Light thickens. The gravitational pull increases. Orbits tighten. Here, the Milky Way glows, with a warm golden hue, its old stars shining like scattered embers. It's okay to drift. You can rest now. Their paths trace intricate loops around the dark center, revealing its presence through motion rather than light. You can rest now. Despite its power, the center feels peaceful from our distant vantage. We watch stars arc in slow curves, light bending gracefully around invisible gravity. Gas spirals inward in faint streams, glowing softly in infrared like warm threads woven into a darker fabric. Somewhere, light continues to travel. We drift outward again, past the bulge, back into the spiral arms, where starlight thins, dust grows, and new stars begin forming once more. The galaxy's weave is cyclical, bright threads of star birth, dark threads of dust lanes, golden threads of old suns, silver threads of white dwarfs, all looping together in a structure spanning 1,000,000 light years. You breathe softly, and the universe exhales through you. A final line closes this chapter. The galaxy is not made of stars. It is made of time and light, learning where to rest. It's okay to drift. Ahead, the fabric of starlight begins to thin. The dark between galaxies opens like an ocean. Beyond it lies the quiet realm, where galaxies themselves drift like islands on slow tides. You can rest now. Light still travels, and you drift with it. The last threads of the Milky Way's glow soften behind us as we drift outward, leaving the warm spirals of starlight to settle into the dark. Ahead lies a wider silence, a silence not of emptiness, but of distance. A silence so vast, it feels like an inhale the universe has been holding for billions of years. You can rest now. Beyond the galaxy's faint halo, the stars thin until they become solitary lanterns scattered across a black ocean. Here, Gravity loosens its tight patterns. Motion becomes slower, longer, more patient. The Milky Way's pull weakens, and other galaxies begin to appear as faint, gauzy forms against the void. You breathe softly, and the universe exhales through you. You breathe softly, and the universe exhales through you. It's okay to drift. Beyond the galaxy's faint halo, the stars thin until they become solitary lanterns scattered across a black ocean. Here, gravity loosens its tight patterns. Motion becomes slower, longer, more patient. The Milky Way's pull weakens, and other galaxies begin to appear as faint, gauzy forms against the void. You can rest now. We drift farther, letting the galaxy fall into a shape we can see entirely. A warm, rotating pinwheel of 100 to 400 billion stars, each one a point of quiet fire. Its rotation continues slow and ancient, completing one turn every 230 million years. A rhythm too large to measure, yet perfectly calm. Somewhere light continues to travel. The space between galaxies is called the intergalactic medium. It is not empty. It contains thin gas, just a few atoms per cubic meter, and faint trails of plasma connecting galaxy clusters like invisible threads. These threads belong to what cosmic scientists call the cosmic web, a lattice of matter stretching across the universe. But tonight, it is simply the quiet between breaths. You breathe softly, and the universe exhales through you. Somewhere light continues to travel. It's okay to drift. The stars inside the Tarantula Nebula burn hot, some reaching 2,000,000 times the sun's luminosity. Yet, from our drifting distance, their glow blends into a single soft wash of silver and blue like moonlight through water. You can rest now. We continue drifting, passing the Small Magellanic Cloud next, a dimmer, quieter galaxy still bound to the Milky Way by gravity. Gas flows between the two clouds in long, faint streams. A river of hydrogen stretching for tens of thousands of light years, shifting slowly over hundreds of millions of years. Somewhere light continues to travel. The Milky Way is part of a small family of galaxies called the Local Group. It contains about 80 galaxies, most of them small dwarfs. Andromeda is the largest, a magnificent spiral glowing 2.5 million light-years away. Its soft blue arms shimmering with clusters of newborn stars. You breathe softly, and the universe exhales through you. Even at this immense distance, Andromeda pulls gently on us. Its gravity and the Milky Way's gravity are entwined, drawing the two galaxies closer by about 110 kilometers per second. One day, far in the future, these galaxies will merge into a single form, a vast, calm ellipsoid of blended stars. It's okay to drift, but that moment lies billions of years ahead. Tonight, we simply drift through the quiet between them, feeling the space widen and soften. The darkness here is smooth, unbroken, comfortable, a deep cradle where time stretches effortlessly. You can rest now. Farther out, the Local Group dissolves into the wider Laniakea supercluster, a sprawling network of 1,000,000 galaxies, all moving along gentle gravitational currents. These currents guide the flow of galaxies the way rivers guide leaves on their surface. In the quiet between stars and galaxies, you are remembered. We drift along one of these currents, now watching dwarf galaxies glide past tiny clusters of tens of millions of stars. Their shapes, irregular but endearing, like soft smudges of light painted onto the dark. You breathe softly, and the universe exhales through you. The voids between superclusters are enormous, some spanning 100 million light years. But even they carry the faint trace of gas, the echo of ancient photons, and the slow drift of dark matter. Nothing in the universe is truly empty. Farther out, the local group dissolves into the wider Laniakea supercluster, a sprawling network of 1,000,000 galaxies, all moving along gentle gravitational currents. These currents guide the flow of galaxies the way rivers guide leaves on their surface. Ahead, a faint wash of orange light gathers. Another galaxy, another island of time and starlight, another quiet world among billions. Light still travels, and you drift with it. The soft orange haze ahead grows clearer as we drift closer, revealing another spiral galaxy floating alone in the intergalactic dark. Its arms turn slowly, so slowly that even 1,000,000 years would pass before the movement seems real. From here it glows like a lantern, suspended above an endless sea. You can rest now. The galaxy is small, a dwarf spiral home to maybe a few billion stars, just a fraction of the Milky Way's glow. Yet its presence feels gentle, balanced, as if it has found its own calm orbit within the vastness. You breathe softly, and the universe exhales through you. We drift along the edge of the dwarf galaxy, watching its outer stars sweep through elongated paths. These stars are old, some more than 10 billion years, carrying with them the chemical signatures of ancient stellar generations. Their light is warm, soft, yellow against the dark. You can rest now. It's okay to drift. You can rest now. You breathe softly, and the universe exhales through you. Somewhere, light continues to travel. Farther ahead lies the boundary where this small galaxy's influence fades. Beyond it, gravity weakens, shadows widen, and the intergalactic dark returns like a colossal velvet silence. Yet the darkness is comforting, a pause between notes, a breath between memories. You breathe softly, and the universe exhales through you. We drift onward into deeper isolation. Galaxies appear as tiny smudges scattered across the sky, ellipticals glowing like distant embers, spirals stretching faint arms across the void, irregulars shining like scattered sparks. Each one is a city of stars, each one moving with the slow rhythm of cosmic expansion. It's okay to drift. The farther we travel, the more the universe's large-scale shape reveals itself. Galaxies cluster into filaments, long glowing rivers, tens of millions of light years long. Between them lie enormous voids, regions so vast that a beam of light could travel for hundreds of millions of years without touching a single star. You can rest now, and yet these voids are not empty. They carry thin whispers of hydrogen, a few atoms drifting across unimaginable distances, cooling slowly in perpetual darkness. These atoms have been here since the universe was young, untouched, unchanged, quiet as dust on an untouched shelf. In the quiet between stars and galaxies, you are remembered. We drift toward one such void now, a region of almost pure nothingness, so still that time itself seems to slow. The faint light of galaxies forms a perimeter around it like lanterns, marking the edges of an ancient clearing. You breathe softly, and the universe exhales through you. Inside the void, the silence deepens. Even gravity feels faint, light diminishing into soft grains, scattered across an endless horizon. Here, the night sky would look sparse stars, fewer their glow, thin and far away. But the quiet feels gentle, not lonely. We drift along the edge of the dwarf galaxy, watching its outer stars sweep through elongated paths. These stars are old, some more than 10 billion years, carrying with them the chemical signatures of ancient stellar generations. Their light is warm, soft, yellow against the dark. A soft truth rises with the darkness. The universe expands everywhere, not from a center, but from every point, every distance, growing, every separation, widening every galaxy, slowly drifting from every other galaxy. This is the smooth, silent fabric of cosmic expansion. You can rest now. We drift deeper still, following subtle gravitational currents that lead toward another glowing strand of galaxies far ahead. These strands form part of the cosmic web, a structure spanning tens of billions of light years, woven by dark matter and illuminated by stars. Somewhere, light continues to travel. As we approach the next filament, the light thickens again. Galaxies gather along its length, clustered like beads on an invisible string. Each cluster contains thousands of galaxies, some spirals, some ellipticals, some shaped by collisions we cannot yet see. You breathe softly, and the universe exhales through you. The scale becomes almost impossible to hold. These clusters stretch for millions of light years. They are bound by gravity so faint anyone living inside a single galaxy could never feel it. And yet, the connection is real, silent, enduring. Inside the void, the silence deepens. Even gravity feels faint, light diminishing into soft grains, scattered across an endless horizon. Here, the night sky would look sparse stars, fewer their glow, thin and far away. We move along one of these cosmic rivers, watching galaxies glide past like drifting lanterns. Some rotate slowly, some shimmer with blue star formation, some glow red with age. All of them float upon the same expanding space. Somewhere, light continues to travel. At last, a soft current guides us forward toward an even larger structure, a region where light gathers more densely, where time seems to hold its breath again. Somewhere, light continues to travel. You are safe here. At last, a soft current guides us forward toward an even larger structure, a region where light gathers more densely, where time seems to hold its breath again. You breathe softly, and the universe exhales through you. At last, a soft current guides us forward toward an even larger structure, a region where light gathers more densely, where time seems to hold its breath again. You are safe here. We move deeper into the cosmic ocean, following currents so faint they can only be felt as a gradual leaning, a gentle pull toward regions where gravity gathers the most light. Clusters drift toward one another over hundreds of millions of years, forming superclusters the size of continents of stars. You are safe here. You are safe here. As we drift, the universe becomes simpler, fewer galaxies, wider distances, longer breaths of space. Everything stretches into quieter shapes. The faint glow around us thins until each galaxy becomes a point suspended on a long thread of time. You breathe softly, and the universe exhales through you. Even superclusters are not still. They flow towards something larger, something deeper, a gravitational basin called the Great Attractor, hidden behind the dense dust of our own Milky Way. It's okay to drift. You breathe softly, and the universe exhales through you. Galaxies beyond this horizon move away from us faster than light can cross the distance. Their glow can never reach here. They slip from view one by one, as cosmic expansion carries them into permanent quiet. You are safe here. The sky around us becomes gentle. The darkness turns velvety, not empty, but soft. A faint warmth floats through it, the cosmic microwave background. This ancient light is 13.8 billion years old, stretched into microwaves by the universe's breath, cooling to just 2.7 Kelvin today. You breathe softly, and the universe exhales through you. It glows with a softness older than every star we've seen, a whisper of the first light the universe ever allowed to travel freely, a hum so even, so uniform, that it has become the lullaby of the cosmos, the quiet sound beneath all starlight. It's okay to drift. You breathe softly, and the universe exhales through you. It glows with a softness older than every star we've seen, a whisper of the first light the universe ever allowed to travel freely, a hum so even, so uniform, that it has become the lullaby of the cosmos, the quiet sound beneath all starlight. Far ahead, a faint shape emerges. Not a galaxy, not a cluster, but a supercluster, filament, arcing like a bridge of stars. It stretches for tens of millions of light years, binding galaxies together in a thin, elegant thread. It glows softly from within its light, traveling undisturbed across ancient space. You breathe softly, and the universe exhales through you. The sky around us becomes gentle. The darkness turns velvety, not empty, but soft. A faint warmth floats through it, the cosmic microwave background. This ancient light is 13.8 billion years old, stretched into microwaves by the universe's breath, cooling to just 2.7 Kelvin today. You breathe softly, and the universe exhales through you. It's okay to drift. Between the galaxies lie vast expanses, regions so calm that gravity pulls almost nothing into them. These voids are among the loneliest places in the cosmos, yet the loneliness is gentle. It feels like the stillness at the edge of sleep, where everything slows and thoughts loosen like dust falling through quiet air. You breathe softly, and the universe exhales through you. We drift along the boundary between void and filament, watching galaxies slide slowly past. Some move with gentle inward pull toward the dense filaments. Others drift outward toward the empty dark. No motion is hurried. Nothing here rushes. You breathe softly, and the universe exhales through you. The universe continues, expanding, stretching every distance, cooling every glow, easing every shape into something softer with each passing billion years. Even the brightest galaxies dim as light stretches into long wavelengths. What was once blue becomes red. What was once red becomes infrared. What was once infrared becomes silence. It's okay to drift. We see a galaxy cluster collapse slowly inward, not in violence, but in a graceful settling. Galaxies spiral gently toward the center over billions of years, forming a giant elliptical shape. Inside, stars move in quiet, random orbits, glowing like slow-floating embers inside a softly lit sphere. You are safe here. You breathe softly, and the universe exhales through you. You breathe softly, and the universe exhales through you. We see a galaxy cluster collapse slowly inward, not in violence, but in a graceful settling. Galaxies spiral gently toward the center over billions of years, forming a giant elliptical shape. Inside, stars move in quiet, random orbits, glowing like slow-floating embers inside a softly lit sphere. It's okay to drift. We slip through the halo surrounding the galaxy, a mist of ancient stars drifting outward into the dark. Each star has wandered for billions of years, carrying the history of collisions, mergers, and the slow folding of light into new shapes. You are safe here. The halo thins. Darkness returns. The galaxy shrinks behind us into a gold-hued ember. Somewhere, light continues to travel. Ahead, the cosmic web reconnects into another filament, another long thread of light weaving itself into the universe. You breathe softly, and the universe exhales through you. Light still travels, and you drift with it. The filament ahead narrows into a gentle bridge of starlight, and as we drift along it, the universe around you becomes even quieter, like the hush of a long night preparing its final breath. You are safe here. Galaxies glow at great distances, their shapes softened by expanding space, their colors stretched into warm embers. Some look like pale smudges, some like tiny spirals, some like faint rings disappearing into the dark. All of them drift with the same slow grace, as if the universe itself is rocking you gently toward rest. You breathe softly, and the universe exhales through you. Farther along, the filament clusters grow thinner, their light dimmer, their motions slower. Cosmic expansion eases them apart until each cluster becomes its own quiet island, holding its stars the way a dream holds its final images before morning fades. Far ahead, a faint shape emerges. Not a galaxy, not a cluster, but a supercluster, filament, arcing like a bridge of stars. It stretches for tens of millions of light years, binding galaxies together in a thin, elegant thread. It glows softly from within its light, traveling undisturbed across ancient space. You are safe here. It's okay to drift low and slow. You are safe here. You breathe softly, and the universe exhales through you. As we drift, you feel space stretch even wider. Galaxies recede, clusters thin, filaments extend into faint lines, and the space between them grows like the slow opening of a dark, calm sea. This is the universe far in its future, not cold, not harsh, but slowed into a peaceful exhale. It's okay to drift. We pass a pocket of darkness where no galaxies remain. Only old photons move through it. Light that has traveled for billions of years, softened into long waves, cool and barely visible. It brushes your thoughts like a distant memory returning in sleep. We pass a pocket of darkness where no galaxies remain. Only old photons move through it. Light that has traveled for billions of years, softened into long waves, cool and barely visible. It brushes your thoughts like a distant memory returning in sleep. For a long moment, the universe feels completely still. Not empty, never empty, but resting. Light from faraway galaxies continues to arrive, but stretched so far it becomes almost soundless illumination, a faint warmth dissolving into your breath. We pass a pocket of darkness where no galaxies remain. Only old photons move through it. Light that has traveled for billions of years, softened into long waves, cool and barely visible. It brushes your thoughts like a distant memory returning in sleep. You are safe here. As we drift, you feel space stretch even wider. Galaxies recede, clusters thin, filaments extend into faint lines, and the space between them grows like the slow opening of a dark, calm sea. This is the universe, far in its future. Not cold, not harsh, but slowed into a peaceful exhale. As we drift, you feel space stretch even wider. Galaxies recede, clusters thin, filaments extend into faint lines, and the space between them grows like the slow opening of a dark, calm sea. This is the universe, far in its future. Not cold, not harsh, but slowed into a peaceful exhale. As we drift, you feel space stretch even wider. Galaxies recede, clusters thin, filaments extend into faint lines, and the space between them grows like the slow opening of a dark, calm sea. This is the universe, far in its future. Not cold, not harsh, but slowed into a peaceful exhale. You are safe here. We drift farther following a corridor of dim galaxies, stretched thin by expansion. Some glow so faintly they are little more than smudges of memory. Others flicker irregularly, their stars aging, cooling, settling into long, gentle dyings. You breathe softly, and the universe exhales through you. The farther we drift, the more the light folds into itself, turning from blue to red, from red to infrared, from infrared to a tender, warming hush. The silence thickens around you like a blanket. It's okay to drift low, easy, and slow. A final soft truth arrives. The universe has never rushed, not in the birth of stars, not in the weaving of galaxies, not in the long expansion of space. And here, surrounded by its unhurried light, you feel its patience gathering around your breath. You are safe here. The glow ahead thins into a gentle shimmer, a last warm remnant drifting across the dark. You float through it calmly, letting it rest on you the way starlight rests on sleeping oceans. You breathe softly, and the universe exhales through you. As the shimmer fades, you enter the quietest part of the cosmic sea, the place where light becomes memory and memory becomes rest. It's okay to drift. Light still travels, and you drift with it.